Stay quiet. Okay, here we go. All right, so Bob starts out at school at 7 a.m. and drives miles in 10 miles in 15 minutes. He then stops for 30 minutes at a local restaurant for breakfast, afraid that he might be late for school. Continues driving a little faster for another 20 minutes and covers 18 miles, at which point the car breaks down. From that point, he jogged the remaining 3 miles to school in 45 minutes. Draw a graph representing what occurred, and then write out each of these equations using piecewise functions similar to the equations in number 8, which was probably the one before. Sorry, number 8 was the problem. I was referring to number 7, okay, for that one. All right, now let me make sure that I am, okay, this is the screen, right? Okay, so now what I'm going to do is, by the way, with graphing, you guys could use graph paper. I'll give you guys graph paper if you need it. All right. You kind of have to think about like the intervals, okay, for this. So what I did was I put time in for the x-axis and I put distance for the y-axis. Okay. And I put in 10, 20, 30, 40, and I did it in increments of 10. And then what? It goes to 120. Okay. All right. And then I did increments of 5 using the distance. Okay. Now the first part is what? 10 miles in 15 minutes. So here's a 10-mile mark. And so I'm going to start here. 10 miles in 15 minutes. So this point is 10 comma, sorry, 15 comma, my bad. 15, 15 comma 10. Then what did he do after that? He rested for 30 minutes, right? So it goes all the way to what? 45, right? So what's the end point there? 45 and 10. We good? Then what happens? Drives a little faster. 20 minutes covers 18 miles. So at 18 after the next 20 minutes, we're at the 28-mile mark, right? So what? That's 65 and what? 28. You guys see that? And then what? He walks, right? For the next 3 miles for the next 45 minutes. So at 110, we stop at 31. So 110 and 31. Any questions on that? Are we good? Now, off the phone. Bella, off the phone. Come on. All right, here we go. So now, here we go. We have to write the piecewise function for this. This is where it's tough. And it's going to be based on y minus y1 is equal to m and then x minus x1. Or what we could do is y is equal to m and then x minus x1 plus y1, right? Remember, it's very similar to the vertex form. Are we good? All right, so you gotta like kind of understand how to do this. The first one's pretty easy. This part right here. Okay, that one is what? So if I write it in piecewise function, what's the slope? The slope is what? You go up 10 and over 15, right? So it's what? 10 over 15, which is y is equal to 2 over 3x plus, what's the y-intercept? 0, right? So that one's just 2 over, or you can just write y equal, or 2 over 3x. What's our interval notation for that one? What's our interval notation? Where the x value is it? Where's the stop? So it's what? 0, 15. Okay. Then he eats breakfast. All right. Bob eats breakfast for 30 minutes right here. How do I represent that in this piecewise function? What's a horizontal line? What's the equation for that? Y equals 10, right? So you just put 10 right here because the f of x already represents the y, right? So y equals 10 between what? 15, comma 45. By the way, with the brackets, if you put a bracket here, then make sure you put parentheses here. Okay? If you put parentheses here, then put a bracket on the next one. Okay? All right? You understand that? So if you put a bracket on the, if you end with a bracket, begin with parentheses. If you end with parentheses here, then start with the bracket on the next one. All right? Then what do we do the next one after that? This is the line right here. How do I get the slope of this line? What's the rise from 45.10 to 65.28? What's the rise? 18. You go up 18 and over 20. So what? Our slope is 18 over 20 or 9 over 10, right? If I simplify it. And start with and plug in for x1 and y1. Plug in the 10 and the 45. So in other words, I'm going to use this right here. Y is equal to 9 over 10, which is the slope. Then x minus 45 plus 10. Does that make sense? All right. All right. Think about that. I put it in point slope form, right? This is very similar to that packet that we had, right? So n is a 9 over 10. 45.10 is the point at which it's starting at. Okay? You good? Any questions on that? That's good. All right, what's our interval notation for that one? Parentheses, what? 45, comma, what does it end? 65. All right. And then the last one is what? Y equals, actually, I don't even have to put y equals because the y equals is here. So y equals, the next one, what's the slope for this last part right here? You go up 3, right? And then over how many? It took him, how long did it take him to walk? It was 45 minutes. So you go up 3 and over 45. Up 3 and 40 over 45. So simplify to what? 1 over 15. All right. So what happens? 1 over 15, and then what? X. And then what's the point that we're dealing with? 65.28. So how would I put that here? Minus 65 plus 28. What's our interval notation? 65 to what? 110. Are we good? All right, any questions on that? Sorry if this is a little messy. I'm gonna erase this here. Cool. All right, let's go to part 2. Part 2 is a step function. All right. Part 2 is a step function. What do I do here? What I'm going to do is I'm going to graph y equals the step function of 2x. That's what I'm going to graph first. So if I do that, and let's just say I go 1.1, 1.5, 1.6, 1.8. Let me try 1.2. So y is equal to what? This is 2 times 1.1, which is 2.2. Step function of 2.2 is what? 2, right? if I did 1.2, 2 times 1.2 is 2.4. The step function of 2.4 is also 2. What happens at 1.5? What's the y value? 3, right? These are all 3. Because y is equal to 2 times 1.5. 2 times 1.5 is 3. The step function of 3 is 3. They all become 3. So if I were to graph this here, at 1.1, here's 1, here's 2. Here is what? 1 and 2. 1.1 and 2 is right here. 1.2 is right here. So all the way up to 1.5, I'll put this in red. The mini step. And then from 1.5, what happens? It comes right here, right? So this and then this. So these mini steps right here, that's the parent. Are we good? All right, now what happens when I factor out the 2 here? Y equals step function of 2 and then x minus 2. What happens there? Right 2. So each one of these goes right 2. So now 1 and then 2. 1, 2. So we'll just move everything over 2 times. And you're good. So just write 2. Okay, and you're good. Are we clear with that? Number 2, find the inverse of the table. What are you doing? What's the simple thing right here? You just flip everything. So 3, negative 3, negative 1, negative 2, my bad. 3, negative 1, negative 2, 0, negative 3, 1, 0, 2, and negative 2, 3. Did I flip them over correctly? Negative 1, 3, negative 1, 3, negative 2, negative 3, 0, 2. Yeah. All right. Is the function 1-to-1? Yes or no? No, why not? Good job. So you see the 3 right here? You see how it has 2 y values of negative 3 and negative 1? All right, so it is not 1-to-1. Okay, cool. So if you flip it and then it is a function, then it is 1-to-1. All right. What if I had a graph, right? It was something like this, and like this, or something like that. Okay, if I had a graph, get each point, let's just say 1, 2, 3, 4, 5. This is, let's say it's 5, 2. Let's say this is 0, 3. Let's say this is negative 2, 0. Let's say this is negative 3, negative 2. And let's say this is negative 5, negative 2. 1, 2, 3, 4, 5. Sorry, negative 6. Be careful with this because just make sure you go in order. Make sure you flip everything in order. All right. So if you flip this, this is what? You want to graph 2, 5 first, then 3, 0, then 0, negative 2, negative 2, negative 3, and negative 6, negative 2, negative 6, and flip them in order. So 2, 5 is up here. 3, 0 is down here. 0, negative 2 is down here. Right? Where am I at? -2, -5 is down here. Am I doing this right? It gets kind of confusing. 2, 3, -2, -5 is right here. And -2, -6. Sorry, -2, -5. Maybe like right here. Something like that, yeah. So you'd have to grab something like that. Sorry, it looks kind of funky, but yeah, that's pretty much what you do. All right, so make sure you go in order. So if you're graphing 5, 2 first, graph that inverse 2, -2, 5 first, okay, and then 3, 0, 0, -2, so on and so forth. All right. All right. Last problem. Yeah.
Can we do the horizontal line on the graphic inverse with just like like the parent? We do a horizontal line test.
So you're asking for, so if you're pretty much, good question. So let's say we have the parabola right here, right? This is the parabola. If it's by itself, what? It's happening. This is a vertical line test, right? What does the horizontal line test do? It tells us if the inverse is also a function, okay? You're not gonna be tested on that one this time around, but just so you know, this is not a function, right? Because it's gonna hit that twice. So the inverse of a quadratic is not a function, unless you only graph a certain part of it, and we'll talk about that as we move on. Okay. Cool. All right. Here we go. Good question. All right, number 3 on this one. Here we go. We're almost done here. Let me just write this all out, and then if you guys have any questions, 2 -2x plus 1. So the final answer is -4x plus 1. This one is 2 times x squared plus 1 plus 1, which is 2x squared plus 2 plus 1, which is 2x squared plus 3. This one is a g of -3 is +6. So this becomes the f of 6. The f of 6 is 2 times 6 plus 1, which is 13. H of 7, which is 7 squared plus 1, which is 49 plus 1, which is 50. Then the f of 50, so the f of 50 is equal to 2 times 50 plus 1, which is 101. Did everybody get those? All right. Number 4 is 23. I'm just going to write the answers down. The f of f plus g of 3, f minus g of 1 is -5. The f times g of x is 3x cubed minus 15x squared minus 2x plus 10. The g of f of x is 3x squared minus 30x plus 73. All right. And the f of g of x is 3x squared minus 7. And since we're running out of time, the last one is a radical function where you shift 4, right 4, up 5. Now, wait, don't go yet. Right 4, 1, 2, 3, 4, up 5. What is our domain? Our domain is 4, comma infinity. Range is 5, comma infinity. Okay, that's what I'm looking for with that one. All right, the domain and range. All right. I will see you on Thursday for any corrections. Unfortunately, I won't see period 6 for corrections, but if you guys need any help with that, let's make sure you come up with questions. All right. was a good one. All right, that was a good brain. Yeah. Brain. I don't know what to say. It really it used my brain a lot. Like yeah, it used my brain a lot. So great exercise. Okay, guys, put my computer back. For today only, I have a meeting till about like 1:45, but after 1:45, if you guys have like a free period, or if you guys are not doing anything in your classes, I am willing to tutor anybody after 1:45 today. So if you guys from 1:45 to when school ends, because I have a game today, but if you guys want to come in at 1:45 for any tutoring, just let me know. I could tutor you during my open. So all right.